Hello everyone. Welcome to session module number 5, number systems, where we discuss mainly numbers. I think this is the only module where we are going to talk about the numbers. I don't think the only one, but this is where we are going to introduce numbers. Uh, when I say numbers, I'm talking about the IP addresses. I think from the first chapter, we introduced with a unique identifier for every device in the network that we call an IP address. We also introduced the MAC address along the way, calling it a layer 2 address, with the IP address being a layer 3 address. All those addresses, they are numbers, right? And understanding number systems is crucial for comprehending how networks function and how data gets transmitted and gets processed. So from a numbers, basically with the number systems, what we're going to do is understanding how do you convert from the decimal numbers that we understand as humans. As humans, we understand what we call decimal numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are decimal numbers. But computers, our networking devices, the language numbers they understand is binary. 1, 0, 1, 0, 1, 0, 1, 0. So understanding how to make conversions between decimal numbers and binary numbers will be very important in understanding how the network works. With the MAC address, you see the MAC address is represented as a hexadecimal number. We define all those terms, hexadecimal number. Also, understanding how to convert from decimal that we understand as humans to hexadecimal, which is the representation of a MAC address, then to binary, which computer systems understand. How do you make those conversions? Basically, that is what we are going to deal with the number systems. So going to the course content, the main objective is to calculate numbers between decimal, binary, and hexadecimal systems. And we're going to be looking at the binary number system and the hexadecimal system. The binary, the binary number system, it consists of ones and zeros. And these are what we call bits. So can I cheat 10 gigabytes per second? It means we are sending 10 billion of those one zeros per second. Is that it? 10 billion, yes. Currently 100 megabytes. We are sending 100 million of those ones and zeros per second. That is what we call currently 100 gigabytes per second. So those ones and zeros are what we call bits. Decimal numbering system consists of digits 0 to 9. And that's 10, but it's 0 to 9. So this is what we call decimal. 0, 1, 2, 9. Right? Host servers, network equipment using binary addressing uses binary addressing to identify each other. Our networking devices, they use binary. They use these ones and zeros. Each address is made up of 32 bits. You see that the IPv4 address, the IP address in short, it is made up of 32 bits. So it has 32 ones and zeros divided into 4 sections called octets. Former sections, while those are the numbers that we see, that if the IP address is 192.168.20.1, this is octet 1, 2, 3, 4. It means this number is represented by 8 bits. 8 bits, 8 bits here, 8 bits, 8 bits here. So it's 8 bits, 8 bits, 8 bits. 8 times 4, making a total of 32 bits. So the IP address is made up of 32 bits, which are divided, grouped into 4 sections called octets. Then if that binary number is converted to a decimal number, that's how we get here. So what we're going to learn basically in this module is how do we go from 192.168.20.1 to, for example, if I want to convert 192, I think 192 is 1, 128, 1 plus 64. Let me do my calculations. 128 plus 64. Yeah, we need a calculator for this one. I'll explain later. Let me get my confidence. Dealing with numbers is not always easy. 128 plus 64, 192. Right. So this is it. 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. This is 192 in binary. So what we're going to learn is how do you go from this to this as easily as I just did. Binary positional notation. Understanding that conversion, you need to understand what we call binary positional notation. Right. As I've already indicated, let's start here. We have 32 bits, 4 octets, octet meaning 8. Right. We are going to use this number 8, meaning we have 8 binary numbers. We're going to use that number 8 to define what we call the binary positional notation. So if, how do I put this? If, let's say 1, 2, 3, 4, 5, 6, 7, 8. If I'm at this position, if there is a 1, let's say if there is a 1 at this position, what it means is in decimal, we have a 128. Forget everything you are seeing there. If we have a 1 at this, it means we have a 64. If we have a 1 here, it means 32. You just keep dividing by 2. 32 divided by 2, 16. Divided by 2, 8. Divided by 2, 4. Divided by 2, 1. 2 divided by 2, 1. 1, 2, 3, 4, 5, 6, 7, 8. These are all the numbers that you need to easily make my conversions. It's called as the binary positional notation. So if ndikaisa 1 panapa ndoisa 0, 0, 0, 0, 0, 0, 0. To convert this number iri binary to decimal, I just look at its position. Kana iri position number 1, it means value is 128. Kana kwesha kune ma 0, it means I don't have anything here. So it means the value yangu here, this number is 128. Example 1. If I have 1 pano as well, let's say panapa pana 0, apa pana 1. That value is now 128 plus 64, meaning it's 192. Another example. This is how you convert. Let's say panapa pana 0 up. Let's change panapa this 1 and 1 up. That value will be 128 plus 16 plus 8, depending on the position. So 128 plus 16 plus 8, 152. So it means this value is 152. And that summarizes how you convert from binary to decimal using the binary positional notation. Let's continue with the other slides. I think we're going to be repeating a lot this. Right, convert. Let's try to convert this one. We have already converted this one. That is 192. I know it. Let's try to convert this one using the binary notation, position notation, binary positional notation. Right. Let's try to convert that. So what we have is 1, 0, 1, 0, 1, 1, 2, 3, 0, 0. I know the first number is 128, 64. Let me not put it. I know this one is 128, this one is 64. Because it's a 0, I'm not going to consider it. This is 32, this is 16, this is 8. So my value is 122, 128 plus 32 plus 8, which is equal to 168, which is the same as, where is it calculated? There it is calculated right there, 168. That is everything that you need to understand. If you're not getting it, you can rewatch the video. It's very simple. So converting, let's convert this one. A little participation. I think we have 3 guys who are there. Let's convert 1, 0, 1, 0, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. What is my calculator? I'm calculating that one. I need an answer from you guys. So the positions that we have is 128, 64, 32, 16, 8, 4, 2. You start with 128 and you start dividing by 2, divided by 2, divided by 2, up until you get to 1. Give me the value of this number in decimal. Very easy. I'll wait for you on this one. We don't continue. I don't get an answer. Let me calculate mine. Mine is so this is here, 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 then plus 3. 163. I'm getting 163, 163, 163. Thank you very much. If 2 guys can get it, everyone can get it. So it's that simple. That's how you convert from binary to decimal. Done. Let's try to find where we convert from decimal to binary. That's decimal to binary conversion. Forget this. We're going to simplify this. Okay. You can as well forget this. All right. Let's find some space. How can we simplify binary to decimal? Okay, let me try this. All right, let's now look at binary. Let's now look at decimal to binary. All right. Binary to decimal, we are done. Very easy. So one last example. Binary to decimal. If I have a number like this, 10110010, 2468, that's good enough. What do we use? We use the position, the binary position. So the first position is value 128 divided by 2, 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 divided by 2. 8 numbers. Position 1, 2, 3, 4, 5, 6, 7, 8. Very simple. So this position means 128 plus 64, 0, plus 32, plus 16, plus 8, 4, plus 2. So what is this value? Is 128 plus 32 plus 16, 128 plus 32 plus 16 plus 2. This value is 178. And we say that's easy. That's very easy. Now let's convert that same value, 178. Let's take 178. Okay, let me not delete this one. There was a 1 there. Let's take 178. That's a decimal number there. We want to convert it back to this number using this same binary position notation. So how do you do that? If I have a number 178, the first thing I do, I look at this position. Is this number greater than this one? If it's not, it means definitely we start with a 1. 128 plus something. So you add up until you get 178. So if I get 128 and I add the next number, 128 plus 64. 128 plus 64, I get 192. 192 is bigger than this one. It means I have to put a 0. Then if I add 32, 128 plus 32 is equal to 128 plus 32 is equal to 160. 160 is less than this number. So it means I can put a 1 there. Now I'm at 160. If I add 16, I get 176, which is less than 178. So I'm good. I'm only left with a 2. So if I add an 8, I will be greater than this. If I add a 4, it will be greater than this. If I add a 2, it will be exactly 178, meaning the binary number for 178 is like this one. That's how you convert from decimal to binary. Very easy. Another example. Let's have any number that you can have which is below 255. You can find it using that binary position notation. So let's have 237. Let's try to calculate 237. Definitely 128. 128 plus 64, 192. 192 plus 32, 192 plus 32. Let me see, 192 plus 32. I'm at 224. So definitely it's there. I'm at 224 now. Then 224 plus 16, 240. Ndapfurira 237. So it means I have 0. I go back. 224 plus 8 now. So this was 16, 128, 64, 32, 16. I go to 8. Plus 8, I go to 232. Definitely there. 232 is less than this one. So at 8, I'm proper. Then if I add a 4, 232 plus 4, 236. I'm proper. I'm not at 236. If I add a 2, I'm at 238, greater than this. If I add a 1, I'm at 237. This is 237 in binary. So that's how you make conversions between decimal and binary. But because it will be very important, particularly IP addressing, very important. But here define a network address in the E, host address in the E. Subnet mask is going to be used to separate this. How do you then separate it? Knowledge of knowing these numbers and how do you convert from this to this and vice versa back. It will be very important. Right. A question. Let's find, don't cheat yourself. Just a Google, go. Let's find binary. Yeah. Any number that you want, you can get it. Let's find 179. 179. It's my zeros, number one's anyone. 179, 2 minutes. I'll wait on you. Let me find mine, Guno. 179. Gonna get a piece of paper. Okay. Let's find 179 in binary. You say my ones and my zeros in chat, man. All right. 1011 179. Yes, that's correct. Right. If two guys can get it, everyone can definitely get it. Very simple. Very simple. There was someone who was asking me, is there a lot of mathematics? And I told him the only numbers you see by my IP address. These are the numbers that you see. The whole of this course. Not a lot of mathematics. All right, let's move. So here we're done. We've managed to convert from binary to decimal, from decimal, and back. Right. IP addresses. Routers, computers only understand binary, while humans work in decimal. It is important for you to gain a thorough understanding of these two numbering systems and how they are used in networking. So I think we are done. We've gone through this one. So this is the conversion from, okay, my pen is now white. Let's see red. From 192 kwenda oku, 168 kwenda oku. It's no longer a problem now at this point. All right, continuing hexadecimal. So the next system we are going to look at is the hexadecimal. This one is a bit complex. Not complex if you understand it. Right, this one counts decimal. Inova from 0, 1, 2, kusvika 9. Hexadecimal inova from 0 ine 16 mabits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So, kana decimal number iri 0 inenge yakafanana kunoku. Hexadecimal number inenge iri 0 as well. Up until ikasvika pana 9 kunoku inenge iri 9 as well. Ikaita 10 hexadecimal inenge yakonzi A. Ikaita 11 hexadecimal inenge yakonzi B. Right. And it's very important to note. Let me go through the text first. To understand IPv6 addresses, you must be able to convert hexadecimal to decimal. I only focused on my MAC address. So two types of MAC address in hexadecimal. The MAC address and the IPv6 address. Anoshansa hexadecimal by representation. Hexadecimal is a base 16 numbering system. So you can see panel 16 my bases. Panel 16 my numbers up 1, 2, 3 up to F, which is 16. Binary is a base 2. Why? Because there are only two variables, 1 and 0. Base 2. This one, it has 16 variables, 0 up to F, base 16. Right. Hexadecimal is a base 16 number system using the digits 0 through 9 in letters A to F. It is easier to express a value as a single hexadecimal digit than as a 4 binary bit. Hexadecimal is used to represent IPv6 addresses and MAC addresses. Okay, proper. So, panapa we have seen a conversion ekubva 0 uyu 0 in binary 4-bit binary uyu 0 in hexadecimal. Let's move and see how do we convert from hexadecimal to decimal or to binary if there is need. This is a format here IPv6 address. IPv4 version 4 ndiyona IP address ine 32 bits. IPv6 you see in a 128 bits. IPv4 32 bits is they are grouped into 8 bits, 8 bits, 8 bits, 8 bits, making 4 octets. With IPv6, we have every 4 bits being represented by a single hexadecimal number. So per 128 bits, total divided by 4, what do we get? 128 divided by 4, we get 32. So we have 32 ma 4 bits, 4 bits, 4 bits, 4 bits in binary. Do I 4 bits, 4 bits, 4 bits, 4 bits, 4 bits. So we have 32 of these. This being 1, this being 2, 3, 4, 5, up until we get to 32. That completes the hexadecimal, the IPv6 address. Now, these 4 bits, they are now converted to hexadecimal. They are now converted to hexadecimal, making up what we call an IPv6 address. Each 4 hexadecimal character group is referred to as a hextet. Okay. Let's move at the conversions. Decimal, so that you can see how do we make more conversions. Decimal to hexadecimal. So let's say we have, let's convert 168 to the. That's a decimal number. 168 is decimal. To convert to hexadecimal, you have to pass through binary. So if we pass through binary, 168 in binary is 128 plus 64 plus 32. I think it works. 128 plus 32, 160. Okay, it works. Then we just need 8. This is 16. This is 8. 168. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Which is the same as this. I think, yes, it's the same. So this is binary. To convert to hexadecimal, you take the decimal, you convert to binary. Then from binary, you group the binary numbers. Starting from the back, you group 4s. So starting from here, to no group 1, 2, 3, 4. Panap, open the first group ready. Then we have 1, 2, 3, 4. This is the second group. So tane 2 more groups. But 2 more groups, why? You find the hexadecimal representation here for my digits our group. So this number is a hexadecimal chi. That's an 8. That's an 8 right here. So we have an 8 up. Then this number is a hexadecimal, starting with the binary representation here, for example. Binary representation here equal decimal ichi. Pangatine 8 ma digits. Tantru kutangira pa 128. Kana une 4 unotangira pa, this is 1, this is 2, this is 4, this is 8. So you can add 8 plus 2. This is a 10 in decimal. But 10 ku decimal, in number ipi ku hexadecimal. Tukadzoka kuno panapa 10 ush ku hexadecimal ngari A. So panapa toisa an A. This means this is an A. So in hexadecimal, this value is A8. That's how you get A8 arapa. It's a hexadecimal. Let's have a couple of more examples. Chibatisik. Let's have another number. Let's convert 236 to hexadecimal. A couple of steps. Number 1, convert to binary. That one is very easy. To go to hexadecimal, you have to go through binary. So when I convert 236 to binary, I have 128 plus 64 plus 32 plus 16 plus 8 plus 4. If I better than that. 1, 2, 3, 4, 5, 6, 7, 8. That is 236 for you. Right. Wapedza, number 2, groups of 4. Starting from the back. That's a problem. Right? So if I group, I can group this one. Meeting is ending. I think we'll finish this one. I can group this one. Then I can group the other one. So this number here is 1100. What is that number in decimal? 8421. That number in decimal is 8 plus 4. That is a 12. So I have a 12 in decimal. This is not hexadecimal, decimal. Then this number is 8 plus 4, 12 plus 2, 14. So those are the two numbers that I have, 14 and 12. In hexadecimal though, what are those numbers? 14, 12. In hexadecimal, 0 to 9 is the same as decimal. 10 is A. 11 is B. 12 is C. 13 is D. 14 is E. And 15 is C. So this number here, 236 in hexadecimal, is represented as E6, EC. That's how you convert from a decimal number to a hexadecimal number. Now, if you want to go back, let's now convert EC to back to decimal. That's a hexadecimal number. Back to decimal. What do you do? Number one, convert the individual decimal, hexadecimal values to binary. 4-bit binary. 4-bit binary. So E it a 4-bit binary, E it a 4-bit binary. What is C? C is 12. Because 10 is A, B is 11, C is 12. D is 13, E is 14. Now, using 8421 to convert to binary, this becomes 1, 1, that's 12. This becomes 1, 1, 1, that's 14. Then you join this. In binary, you join these two numbers. So we have 1, 1, 1, 0, 1, 1, 0, 0. Then you convert this to decimal. 128 plus 64 plus 32 plus 8 plus 4, which gives you 236. Right, let me see slide rangu rasaronishi because I think tatopedza hexadecimal to decimal ratopera. One example for you. Let's see who gets this one. Let's have a number. Let's have which number are we going to have? Let's convert 199 to hexadecimal. Hexadecimal. All right, let's give it a go. Tipete on chat. We have 6 minutes with tipete. I think we can get this done in less than 6 minutes. 199 to hexadecimal. Let's give it a try. And I think that closes our number systems module. This will be very useful, by the way. Very. But my concepts are actually akabva. Kana kuzoshanda. I'm not scaring anyone. Kana kuzoshanda usingamazivi. It becomes very difficult to understand. It's very easy, by the way. It's very easy to compare, but you must know understand the underlying concepts. 199. Let me try to find my own answer. 199. Convert to binary. I hope we have some guys working behind the scenes. How about that? Hey, hey, C7. I hope you are not copying this. You're actually calculating. Okay, let's give it a go. Hey, that's not to pizza. Hey, guys are serious. Okay. So 199. Let's work out 199 together. Just the last example, 199. So we convert it to binary 128, 192, that's around 5. 32, 16, 8, 4, 2, 1. This is 192 plus 4, 196 plus 1, 197. So we need a 1 day. Is this correct? I think this should be correct. 192, 193, 195, 199. This is correct. I hope this is the same thing that you got. Then to divide the panel, then this is 4, 6, 7. This is 8, 4. This is 12. So the 7 remains the 7. This is a C. This is a C. 10A, 11B, 12C. Thank you very much. C7. And ladies and gentlemen, that concludes session ready Riemann number systems. We are done. Thank you very much for your time. Refangana in the next module where we discuss the data link.